Hey guys, these are notes for geometry, Unit 1, Section 1, and hopefully you were able to print out your notes on the website. There's a place for you to click on the Geo Notes 1.1, print it out, and then all you have to do is just fill in the blanks, which should make life a little easier for you. Each notes I'm going to hopefully start with a mad gab and a number stumper. Not going to give you the answers to those, but if you write your answer on a small piece of paper, scratch paper, scrap paper, and put your name on it, put your answer on it, fold it up, and bring it to me tomorrow. I will pick one, and we'll see if you get it right. So those are just little challenges. So here's the first mad gap. You don't have to write these down if you can, if you want to. A jar, Coke, real, and your job in a mad gap is to say it really fast so that you can see what it really says, what phrase would it really say if you were to say those three words really fast together or put them together as like one big thing. What phrase could it make? And then there's a number stumper, which has a number in it, 18, H on a GC, and you have to figure out what the H and the G and the C stand for with the 18, because these are all real world numbers. And this is just for a fun little math tip for the day, a little cartoon that I saw. Here's a little math tip for you. Math tips 5 cents. The tip says do your homework. You know that's so important to do. Hopefully you do your notes. Fill in your notes. It really will help you on your tests and quizzes. To have notes to study, to have notes to use on a quiz. It should help you quite a bit. First notes 1.1 are on points, lines, planes, and angles as well. So the first part we want to look at when we're talking about points, lines, and planes, we're talking about different dimensions. A point has no dimensions. It's just a dot. And we're going to talk about a point, filling in some of the blanks here. A line has one dimension, length. A square or rectangle or whatever has two dimensions. It's got a length and a width. And then a solid will have three dimensions. It's got a length, a width, and a height. So those are just different dimensions of some of the different shapes that we will be seeing. Now as far as points, lines, planes, and solids, you can see a point has no dimensions. It's only a position. It's a place that you put the dot at. A line is one-dimensional. Has one dimension, just length. Like I said, this line right here just has a length to it. There's no width, no thickness, nothing. A plane is two-dimensional. We call it 2D because it's got a length and a width. And a solid is three-dimensional. We call it 3D when it's got a length, a width, and a height. Now you can pause the video anytime to catch up. I move kind of fast through these, so I don't want to make the video too long to upload, but you can always pause it and fill in any of the blanks. A point is an exact location. It has no size. It's only a position. And there's a website that I'm going to be using quite a bit called mathisfun.com. Now, if you're watching this on a computer where you can open up a second window, I would definitely encourage you to do that. And in that second window, go to mathisfun.com. Now, in this case, we're going to be going to the geometry and the point, so we can kind of analyze what a point is. And it's the same thing that I told you here, but on these points you can drag them around and say, okay, that is just a location. I could drag this down to this location if I want to. I can drag B up to this location if I want to. So a point is just a location. It doesn't even have to be on a line. It could be in between lines. It could be halves or quarters. So a point is simply a location. And I would, play around with some of the things that we're going to be doing in our notes. So if you have another window open to mathisfun.com, I think that would really help you. Now back to the note part. So you can drag the points and show that has really no size, just a location. Now the exact location of a point can be shown using Cartesian coordinates, the x and the y coordinates. And you can also see that on that website that we were talking about down here, Cartesian coordinates. You can see where I got these pictures from because it's a great illustration to show you how things work in math. Okay, so Cartesian coordinates, this is the point 12, 5. You go over 12, you go up 5. That's a location. This Cartesian coordinate is the location of this point. So here the point we have is the point 12, 5. So points are locations only. Lines is a line is straight. It doesn't curve at all. We would call it a curve if it's a curve, or an arc. And here, if it's a line, it's going to be straight. It has no thickness. It's just a line, and it extends in both directions without end, infinitely. So if we call it a line, that means we could say it's going on forever in both directions. A line has no ends. It does not end at all. Again, if you're on your Math is Fun website, there is also a little thing for a line. You can look at it, you can play with the line, you can move these 2 points around and show that that line will continue to be straight all the way around without end. You could play with it, move it around. Now this is a drop down that gives us also a line segment and array, which we are going to talk about here in a second. So let's go back to this for a second. It has no ends, goes on to infinitely. And again, if you need to pause it to fill these in, just pause it and fill them in. A line segment does have endpoints. It does have ends, and it's called a line segment. So if it does have ends, like this end here and this end here, it's called a line segment. So go back to the website for a second and click down here to a line segment, and you can see that now A and B are going to be the 2 endpoints. And you could put them anywhere you want to, and you'll always have a line that connects those two, A and B. So you can make them super close together, you can make them super far apart, and you'll still have a line that connects the 2 of them. That's a line segment, because it has endpoints. How many line segments can you find in this cube? Pause it right now and see how many you can count, and then turn it back on and see if you got it right. So pause it right now. Okay, so if you paused it and tried your guess, did you guess 9? Because there are 9. There's actually 4 on the top. Line segments can you find in the cube on the right? We got 4 on the top. We got 2 here on the bottom, and we got 3 here on the sides. And you know, we know there's more on the back, but just the ones that we can see. Ones we can see, you got 4, 5, 6, 7, 8, 9, the ones that you can see. If we listed them, AB would be a line segment, AG would be a line segment, and these are all the ones that we can see. Now how we would notate a line segment is we would take a little straight line across this like that, and that would be telling us a line segment. Now it's not an arrow, a line with arrow, that would be a regular line. This is just a line segment. Sorry, I have to get these rid of these for you. Okay, so line segment, if I can get this is going to come here. And all of these would have little line segments on them. You could put on all of them. Now the next type is called array. Now a ray, it's called a ray if it has just one end. If it's one end, it's called a ray. So again, you could go back to that same place, click down on array, and you can see that A is the only endpoint. Now I could put A anywhere, and it's not going to go past A. The A is, but it's always going to go in the direction toward B, because it's the endpoint is A, and then it goes in the other direction. So that would be called array. Now keep in mind, all you need for a line are 2 points. 2 points make a segment. 2 points make a line. You need at least 2 points to make an array, but array continues in one direction forever. A line goes in both directions. Array only goes in one direction. So that would be array, one direction, like a flashlight. Okay, a plane is a flat surface with no thickness. A flat surface with no thickness. In our world has 3 dimensions, but there are only 2 dimensions on a plane. There's length and width that make a plane. X and Y also make a plane, and a plane goes on forever in both directions. Now let's take a look at what a plane looks like. So if you go to the Math is Fun website, and you look at a plane, there's a little thing here that shows us right here. You can play around with the fact that it's like a flat surface with no thickness. It's just flat. So I can drag it around if I want to, make it look like, or I can just have it spin. You can kind of see it. That's what a plane looks like. It's flat. Both sides are flat. You got lines on the plane, because lines don't have thickness either. Plane doesn't have thickness, lines don't have thickness. Now, a plane, here's some examples. So you can kind of see right here what the plane looks like, and an arrow showing that it goes on forever. When we draw something on a flat piece of paper, we're drawing on a plane. The paper itself is not a plane because it has thickness, and it should extend forever too. So if you can picture a piece of paper as a plane, but you can only picture like the side of the paper as the plane, not the thickness of the paper. So the very top of a perfect piece of paper that goes on forever is the right idea for a plane. Also, the top of a table and the floor and a whiteboard are all like a plane. Just the top of it, not the thickness of it. You can't say the thickness of your desk or the table, but you could say just the top of it would be the plane. Again, pause the video if you need to. Plane versus plane. Look at the different spellings. In geometry, a plane is a flat surface with no thickness. But if you spelled it P-L-A-I-N, then you're talking about a mostly flat expanse of land, like the plains in the Midwest. It's also flat, but in a pure sense, not in the pure sense that we use in geometry. We use the word plane, P-L-A-N-E, to show a flat surface. Now, the way we spell it, P-L-A-N-E, can also mean airplane, or level, or a tool for cutting flat things. So you need to be careful when you think of the word plane. There's a little activity for you to do. Imagine you lived in a two-dimensional world. You could travel around, visit friends, but nothing in your world would have height. You could measure distances and angles. You could travel fast or slow. You could go forward, backwards, or sideways. You could move in straight lines and circles or anything so long as you never go up or down. What would life be like living on a plane? Just give a little couple of sentences there on what you think it would be like to live in a plane or on a plane, just a plane. And pause the video while you do that. I'm going to move on. All right, here's the next one. Collinear. Collinear. When three or more points lie on a straight line, we call them collinear. Co means together. So together on a line. Collinear means together on a line. 2 points make a line, so they would be called collinear. So you can kind of see, you could draw the line right through these 4 points, and you would have collinear points. Alright, let's check out the collinear points here. Math is fun once again. And you can see what the collinear. Now look at these 4 points where you can drag A somewhere, but look what happens to B, C, and D. They all stay on the same line. Look, I could even pass these. They're always going to line up. That's called collinear. I could try to move C out, but then all the rest of them move to always keep them collinear. So collinear means they're always going to be together on the same line. So draw a line through your points on your notes to show that those 4 points are collinear. They're on the same line. Now just a quick review. Collinear means points on the same line. Coplanar, if you put the co in front of the plane, that just means points on the same plane. So collinear on the same line, because you see the word line in there. The word plane, so planar. And the word co, or the prefix co, means together or jointly. It means when you're putting things together on the same line. So A, B, and C are collinear here. D, B, and E are collinear. So list all points collinear with point A. What would be points B and C? So you would put point B and C would be collinear with A. Coplanar with F, well, you've got A, B, G, C. So you got A, B, G, and C. They would all be on the same plane as F. Now D and E are not on the same plane. They're above and below the plane. they are coplanar themselves because they're on the same line. There's a different plane that would be going through those 3 points. All points that are coplanar with D would just be B and E, because anything that's collinear is also coplanar. So you could put collinear points are also coplanar points. And again, pause the video if you need more time to write those things down, but those are just coplanar and collinear. Intersection, where do things meet? Where do things touch? Well, 2 lines are going to touch at a point. The intersection of 2 lines will always be a point. 2 planes, like I was telling you earlier about the planes, or the 3 points that had its own plane, like this plane right here would be in that line. 2 planes touch in a line. So if you were to connect 2 planes, that would make an intersection, would be a line. So here's a diagram that shows that the intersection of 2 lines is a point. Here's the diagram that shows that 2 planes together would make a line. Counterexample is an example that proves a statement's false. Just giving you some of the key vocabulary words. So here's something. All lines contain exactly 1 point. If I was to say that all lines contain exactly 1 point, you would show a counterexample by AB containing 2 points. So that would be called a counterexample because it proves that my statement was wrong. It proves that all lines contain more than 1 point. If it's just 1 point, then it would just be a point, not a line. So you gotta have at least 2 points to make a straight line. So that's called a counterexample. When you prove a statement to be false, we call it a counterexample. These are the longest notes. There's 12 slides here. Most of them do not have this many slides. This is kind of a beginning, just to kind of get the vocab terms out of the way here. In solid geometry, the geometry of 3 dimensions. So there's really not a whole lot to write on here because we're not going to cover this stuff till near the end of the year. So we've got width, we've got depth, we've got height. Just wanted you to know what 3 dimensions was. It's called 3-dimensional or 3D because there are 3 dimensions. There's a width, a depth, and a height. Or you could say a width and a length and a height. The same thing there. So that's just a little vocab on solid geometry, and what we're going to be studying later, we're going to be finding like surface areas and volumes and things like that. So that would be solid geometry. Now for angles, the last couple of slides here on angles. An angle is formed by 2 rays. It has a common endpoint. So if you go from A and you're going this direction towards B, that'll be ray N. If you start at A and go this direction towards C, that's going to be ray M. Angle 1 is what was made by those 2 rays. Okay, so ray AB and ray AC form angle BAC, and we would use this notation, angle BAC. It almost looks like a less than sign, but it's straight across here. So it's angle BAC, and this point right here we would call vertex. It's the vertex of the angle. It's the place where the 2 endpoints meet. The place where the common endpoint is called a vertex. Now there's another cool slide on mathisfun.com that shows you about the different kinds of angles. Now I didn't make you write any of those in. We should already know an acute angle is less than 90. A right angle is exactly 90. Obtuse is greater than 90, but it's less than 180. Straight is exactly 180, and then reflex might be a new one for you. A reflex angle is an angle that's greater than 180. So if it's bigger than a straight line, like you can see down here, we call it a reflex angle. It's more than 180 degrees. A full rotation, of course, is 360. So look at this little picture right here. This kind of shows you exactly. Got 15, 45, 16, and 90 shows you it's a right angle. And then as you get bigger and bigger and bigger, it comes down to 180, which is exactly a straight angle. And all these are reflex angles down here, and then you get a full rotation. This is a great diagram to show you all the different kinds. And you can try it yourself. You can use your mouse and say, okay, all these are acute angles because it says acute right here. But if I go up to here, it says right angle. And then if I move here, it's obtuse. If I come below that, it's called reflex, all the way around. Reflex are all the way on the bottom. And then you got your full rotation. So you could actually try that, and it kind of, you can even draw the angles in there too. So it's pretty cool. So try it on your own computer. And this is a great diagram. I believe I put it in your notes on the next page here, and you can pause it if you need to fill stuff in. But this diagram right here really shows you there's your acutes, there's your rights, there's your obtuses, there's your reflexes, and it gives you all of it. And acute, obtuse, and reflex are in alphabetical order, so you can go A, O, R. You can say, okay, that's how I could remember them, is that they have to go in alphabetical order, except for the right angle. But the three areas of angles would be. But be careful what you measure. This is also in the Math is Fun website, is that, this angle, these two angles are the same exact in lines, but if I measure the inside, I'm measuring the obtuse angle, which is 130. If I'm measuring the outside, I'm measuring the reflex angle, which is 230. So this one's obtuse and this one's a reflex because of the difference of where I'm measuring it. So be careful what you measure, and always notate what it is you're measuring with letters. But the lines are the same. So when naming angles, make sure that you know that which angle is being asked for. Your parts of an angle, the corner point is called the vertex right here. The two straight sides are called arms of the angle. And the angle is the amount of turn between each arm. How far did you turn between this arm to this arm is your angle. That's the inside part. Now it could be the outside part as well. You might have started here and come all around like this, and you might have been doing the reflex angle. So be careful what you measure. Again, pause it if you need to. Last slide here is just some symbols. I didn't even make you fill in that much, just the meanings, all I wanted you to fill in. So these meaning, it's a triangle, it's an angle, perpendicular, parallel, that's two little lines next to each other. Degrees, a right angle, line segment, a line. But look these over because these are important notations. It saves you a lot of time having to write everything out by just using the notation. So here's a congruent symbol. It's just like equals, but it's got the little squiggly on top, and it means shapes are the same size. You still use equals if you're talking numbers. You use congruent if you're talking shapes. Similar means they're proportional. And then three dots is therefore. We don't use that much, but we could. When someone says in triangle ABC, angle BAC is perpendicular, they are really saying triangle ABC, the angle BAC is a right angle. So just look and see how they write stuff down. All right, you guys, make sure you cut those out and paste them into your spiral notebook, and we'll see you guys tomorrow.